talks, a brief introduction of who I am. Sam gave a much better introduction of who I am and what I do at Ippon. If you guys are interested, I can send you the slides later. Right, so this is the thesis of the talk, that events decouple DQM jobs from ETL jobs. And I'm going to try to attempt to convince you that that is true by the end of this talk, through various examples and discussion on DQM and ETL. So what do I mean by DQM and ETL? DQM and ETL are two industry acronyms for data quality management and extract, transform, and load respectively. And I'm positing that events break those two sequential tasks apart from each other, so that you remove the stateful nature that ETL jobs impart onto DQM jobs, allowing DQM jobs to function independent from your ETL jobs while still remaining informed by your ETL jobs. And this is common practice through events. If you're familiar with event-driven architectures, this is not something that's going to be new or groundbreaking to you. This is just applying those concepts to ETL and data quality. So if you're not familiar with event-driven architectures, these are the typical components of an event-driven architecture. There's 4 that you definitely have to have. You might have 2 more. You have the message bus, which is some kind of architecture that will route traffic across or route events from a source to a destination. A routing protocol, this is a general term for topics and queues. Some event architectures use UDP networking. Some are just TCP networking, like just peer-to-peer. You have event producers that will create the event, and event consumers that will read the event or consume the event and take action once reading it. Sometimes, for those of you that are familiar with Kafka, you'll have a schema registry, something that takes common events and binds them to types. This is kind of a cool way of normalizing all your events. And excuse me, for those of you that are also familiar with Kafka, you may also have streaming analytics over your event bus. This is kind of a newer concept. Kinesis does this as well. This is a new area in event-driven architecture that's coming out with a lot of different updates and changes as they go, as time goes on. But it's still technically optional because many event architectures really don't need it. So as you lay all of these components out, this is what it would look like. You would start with a schema registry, possibly, where you would pull an event schema, populate it with the data from your producer, send it over the message bus using routing protocol, have your routing protocol route that to the proper consumer, running analytics over it using something like KSQL or Kinesis Analytics if your use case requires it. So there's a bunch of different event buses out there. There's no one right message bus. There's definitely a wrong message bus, and that's based on how you use it, how you want to put events into your architecture. For example, if you don't care about having a historical log of events, you wouldn't choose Kafka. If you don't need low latency events, you wouldn't choose Solus. The list goes on. There's a bunch of different ways you can choose a message bus. We'll talk more about how you would choose or why you would choose a message bus for breaking up ETL and DQM jobs later. The point is there's a bunch of different message buses out there, and you have to take good care in selecting one before you start implementing what I'm going to recommend in the rest of this talk. So this is kind of a summary of the problem statement. ETL and DQM workflows are both inherently stateful processes. ETL jobs extract from an upstream system, manipulate the data, and load it downstream. DQM jobs confirm that your ETL job ran in a good amount of time, that the data it pulled is the data it said it was going to pull, that the downstream system matches the contents of the upstream system, the transformations all acted properly, and any missing records are accounted for and can be rerun through the ETL flow automatically. This is the problem, though, is that DQM jobs rely on the outputs of your ETL jobs. And your ETL jobs will never know if they are performing at a high quality unless your DQM jobs are working as well. So one kind of feeds the other, and so you have two snakes kind of eating each other's tails. So the way to break this up is using events. Let's look at a typical ETL orchestration to see where DQM might fit in. This is your basic flow. So using something on AWS, you start with an upstream system like RDS. You have an AWS data pipeline acting as the orchestrator of your ETL job, showing how many attempts the job ran, did it run successfully, things like that. Very high level metrics on your ETL job. The ETL job itself would run inside EMR, for example, as a Scala job. And then you would load the data into Redshift for analysis later. You can also have stage storage in S3 for raw or conformed data store, like if you maybe want to manipulate your database files and put them into Avro or Parquet. And you have a glue catalog to read the data and help you inform your business decisions based on what's in your warehouse. So where does DQM fit into this process? You could technically cram it into your EMR job, but if you wanted to use microservices to break this up, you could have a very similar flow where you have raw storage, writing in raw and conformed data into S3, your EMR ETL job writing into Redshift, and your data catalog running on Glue. But then you can also have a Lambda function that runs this thing called ABC and writes into DynamoDB, where you can have DQM data, DQM outputs stored. So what data are we collecting in our DQM jobs, this Lambda, and what is this ABC thing called? What does that mean? Well, let's start with the first one. This is the information that you're actually collecting from your DQM job. This is a sample schema that we actually implemented at a customer of ours. We use this to impart some DQM on a greenfield deployment of a data lake, data warehouse on Snowflake. And this is a sample schema of what we did not implement job params because I just didn't need it. But this is a sample schema of the kind of information we collected using Airflow as an orchestrator and the data about those ETL jobs that we collected to enforce DQM. Some of the sample information that we collected in this case would be the name of the job, how long the job was supposed to run, if the job was still considered active, who created it, therefore who could be responsible if something went wrong, where we could, if we had to chase up issues. Some of the other information about individual job runs we collected in the job run table were like information about the total records read versus the total records written downstream, that is. How long the job took to run, implying that maybe we need to break up this job into smaller, to read smaller chunks or to run more frequently. And because we used Airflow at this particular client, we broke everything up into individual task runs as well, so that we could keep track of the parameters for tasks that were executed in case the parameters changed over time, or if we needed to tweak those parameters, or if something went wrong, we could see what was fed into the task before it ran. And this was something that we used pretty effectively at a client. And this is not the end-all be-all example of what kind of data you want to collect in your DQM jobs. This is just a sample of what we needed for this customer and what the customer needed to enforce a high level of data quality in the very infant stages of a data lake. As your data analytics jobs and as your ETL jobs get more and more advanced, you probably want to collect more data or break up your DQM schema into more detail. For example, the ETL job param I mentioned, we didn't really use this, but this might be something that you want to flesh out a little more if you have a more mature setup. So this is the kind of data you would be collecting in a DQM job, but what are the ABCs of DQMs? This is back to that diagram I mentioned before. What are these ABCs? This is what's running inside in this sample architecture. This is what's running inside the Lambda that eventually populates your DQM store. What are these ABCs? So if you've been following our LinkedIn page, you may notice that there are some blog posts on exactly these topics. The ABCs stand for audit, balance, and control. Audit is about to, actually, I don't think Audit was published yet, but Audit is about to be published and Balance and Control are coming. Audit, Balance, and Control are the ABCs of DQM. What does that mean? It's kind of like Audit really just captures information about where your data is coming from and that your pipeline performed the way it was supposed to perform. Balance makes sure that your upstream and downstream systems have the same exact data in them, taking into account any transformations you've performed in your ETL pipeline. And Control is the automated framework, or hopefully automated framework, around fixing issues that arise during your ETL process, triggering new ETL jobs on the fly, and generally resolving errors that have been highlighted through the audit and balance process. So this is a sample audit process. A very watered down architecture of what this might look like. You can have your RDS, your upstream RDS system, your source of data, and you can have your audit job running inside, for example, AWS Lambda, and you can run some checks to see like how many records did you pull, how many records are stored in Redshift for the same timestamps, where the time is equal to the time after the last insert, for example. And you can store all of this information inside your downstream DQM store. I'm showing DynamoDB here because DQM is pretty flexible and pretty loose. It's only relevant if it informs your business use case. So that may be changing quite a bit. That's why I'm recommending a NoSQL DynamoDB style downstream storage system for this. But you can store things like SLA hit or miss. Is the job still running? The state of the upstream database, if you want to store something like that. The state of the downstream database, if that's something you're interested in storing. It's generally an audit of how your ETL processes are working, or how a specific ETL job is working. The balance process is a little more complicated, simply because there's so much that could go on in the balance process. The idea behind the balance process is it tries to solve the issue where your ETL job ran and the data that's in your downstream system does not reflect or cannot be traced back to your upstream system. You're missing records, or your records have been transformed so that they don't reflect the true state of your upstream data store, things like that. So balance tries to solve this problem, and there's a lot of different ways it could work. I've heard stories of people writing thousands of lines of business logic queries, very complicated queries that do checks against two separate data stores to make sure that the data lines up. And that data may not always be string comparison. It may just be checking to see if a transformation has run effectively. And for OLTP databases, this could be really, really complicated. So for this sample diagram, the sample architecture, I'm suggesting you pull balance queries from S3, and there are already pre-written queries that you could just run against both sources of data, and do maybe like a checksum against the results. You do some string comparisons. It really depends on your DQM job and what you're trying to assure. But at the end of this process, you should know if your upstream data store and your downstream data store are balanced, or if they have the same exact data in them. So your control process is probably the most interesting process, at least in my opinion. Your control process could be informed by your audit and balance process to re-trigger new ETL jobs to fix errors that were missed in the original job. So breaking that down a little bit, when you run an audit job or a balance job, or really when you run both, you should, at the end of that process, have a list of records that were missing from either one or both data sources. So your control job should be able to say, okay, I'm missing these records from my downstream source. I'm going to go rerun a new ETL job with exactly those requesting exactly those records, performing those transformations and reinserting the data into my downstream store like Redshift. That's where control jobs really shine, and that's what makes DQM pretty powerful. But now you can start to see how complicated this can get, because in order for control to work, you have to have collected all of the data that audit and balance collect throughout their throughout the DQM job. And you really need to know exactly what information you want in terms of ensuring your data has a high quality before you can start running control processes. Otherwise, you'll just be rerunning the same ETL jobs over and over and over again, or you may never run a job at all. So I'm going to pause here for questions, because that was kind of a lot, and that kind of really went over ETL at a high level and DQM at a high level. I'm going to pause here for questions if there are any.
Yes, I have a question.
Sure.
In the ABCA, what that stands for, I forgot. But anyway, I understand it's easy to check the I would say static value, like you measure the counts. You also mentioned there's whether the job is still running, is still alive. How to check that? I mean, the dynamic, like the job itself.
Right. So that specific example comes from the client we worked with. If you've never used Airflow before, it's pretty cool in the way that it has the ability to toggle jobs, and you're able to actually hook into the toggle action that happens on the Airflow UI. And if you hook into that toggle action where you turn the job off, you can actually you can actually perform something programmatically when the job is turning off. And so that's where that specifically is where that comes from, in this example at least. But it's pretty generic. You could have your audit process, for example, could check to see if we're running processes on an EC2 instance. Say your ETL job is just a shell script that's running all the time, and you can check to see if you just do a PS and grep for the ETL job name, which you should have by virtue of the upstream process. The upstream ETL process should inform that DQM job of what the job's name is. So you can tell if that job is still active or if the job dies, for example. Granted, you may never have run the DQM job if the upstream job never fired the DQM job. So I can see where you're saying like this may be like redundant information, but it does depend on your implementation. Because even if you have something like if you have Airflow running orchestrating your ETL jobs, you can still fire off events on a periodic basis that would trigger your DQM jobs to check to see if your jobs are active.
Thank you, very clear. Yeah, thank you.
No problem.
Hey Dan, have you had good success with placing the interpretation out of the recording of the metrics, so that those two are separated, so that you have a record, counts and everything, and then you may have an interpretation job to say these are different, therefore this is a pass or fail.
Okay. Yeah. So typically, what we've done in that case is we never got to a level of advancement on this client site where we implemented this, where we could have monitoring that would do that for us. That was scoped work, but it never ended up coming to fruition. But what we would end up doing is query the DQM table to see the DQM ETL job table or job run table to see if the records read were equal to the records written. Actually, I have it written here. To see if the records read were equal to the records written, and we would create a view for that. And that view would be updated daily or every time the DQM table was updated. And we would just see, we could just go down the line using using Snowflake. We could just go down the line and see what jobs did not run the way we expected them to. And that really helped us isolate DAGs. At least in this case, they were DAGs because we were using Airflow. helped us isolate DAGs that needed to be that needed more troubleshooting, more debugging work, more sprint time allocated to those DAGs specifically.
Thank you.
To your point, though, you could very easily have a separate field where if it's greater than 0, then one records read is greater than the records written, or vice versa. Take the absolute value of that, and you can alert on the difference very easily. Cool. So I'm gonna move on to event-based DQM integrated with ETL. So typically what would happen without using events, to implement something like this, you have two options. You either smush DQM in with your ETL. So you have a giant ETL DQM job. That's could work, but it's very difficult to extend because now if your ETL, you don't have generic data quality management anymore, or you don't have generic ETL anymore. You sacrifice genericism with smushing the two processes in together, and it's generally bad practice to have two disparate processes running, or two disparate tasks running in the same process. So the only other alternative is to have DQM run after ETL, and that's definitely doable as well. But your DQM job becomes reliant on ETL to run. And you could potentially have your DQM job waiting, and never actually running. And on the other side of that, if your ETL job runs and your DQM job then runs after that, you have to wait for your DQM job to run and finish before you can fire off the same exact ETL job down the line, unless you have two ETL jobs running at the same time. And now, when did your data quality management job start or stop for the first job and then start for the second job? So it gets a little convoluted. Probably okay practice for small setups or for large batch jobs that will only run once a week or once a month. But typically speaking, it does open you up to those kinds of headaches. That's where events come in. So this is a sample architecture using events. You would have, in this case, I'm showing an event bus using SNS and SQS. The ETL orchestration looks much the same as what we had before, except you have a Lambda notifier that runs as a separate task inside your data pipeline, where it just spits out an event that says, hey, this ETL job is running. I need you to run data quality on it. The SNS job runs, and then the SQS job runs. The SNS message, the SNS topic receives the message, SQS receives that message on that topic. You could potentially configure some polling, like a timeout on when that message becomes available in SQS for a downstream process. And then you can have step functions run after the SQS message has been visible on that queue. And your step function can contain all the different lambdas that are now broken up by topic, audit, balance, and control. So now there's separate lambdas that run inside your step function, and now you have a separate orchestrator orchestrating your ETL job or your DQM job, just like you have with ETL. And if something goes wrong with DQM, now we can say, okay, this is where something went wrong. We know, and if you've never used step functions before, it's actually really cool. You can see the number of jobs ran, job success runs, job fail runs, and you can go into each step and see what the inputs were and what the outputs were, etc. And then you have your DynamoDB at the end. So this is the sample, kind of switching gears to the event space now. This is a sample event that you could potentially send to your downstream job. This event is in JSON, and it contains the information about your ETL job that you may want to persist. For example, job ID, which could be auto-generated, task ID, an array of tasks that are running inside that particular job, parameters that were sent over, like a mapping, records written versus records read. Notice there's a difference here, so this should raise up a balance job, or the balance job should raise this and trigger another ETL job through the control process. The moniker for the source system and the destination system. You can store your staging data system, your staging system here as well if you want. It might be worthwhile to store the S3 URL for the staged data. Fields that you want to balance on in particular. Your ETL jobs may pull everything, but you don't want to balance on everything. Maybe you only want to balance on the transaction cost or something like that, or number of widgets sold. That's where you can put, for example, a balance field here and say, hey, we're going to store and balance on exactly this field. I don't really care about widget name so much. I really care about widget ID and widget count, not necessarily widget description. Balance queries can be, you can point to balance queries for a specific set of queries that you want to balance on. This allows you to potentially even have source controlled balance queries later on down the line, where you have, you can update your queries and keep track of versioned queries as your DQM jobs grow and get more complicated. And then, of course, logging, if you're interested in keeping your logging data for your ETL job. This may be important, and this may actually offload a lot of work in your audit and balance jobs if your logging is verbose enough. If your ETL job is telling you exactly what records were pulled, then it may be more in your interest to send the S3 log location instead of making balance queries, so that you can reverse engineer the logs to know exactly what records were pulled and what records were manipulated, and what records should have been manipulated that were missed. So it gets pretty, you can be pretty creative with this. There's a lot of different ways it can go. And this is a sample of an event mesh. This is something that Solus created using their recent cloud offering. It's a really cool tool. If you've never worked with Solus before, it used to be relegated mostly to financial services, but now they're coming out with cloud offerings that make it much more accessible. You can see here that in this example diagram, your upstream ETL job can trigger an ETL orchestrator that will fire off events, either sequentially, where you go around in this circle, or serially, where you kind of go in a hub and spoke model down to your DQM aggregator, which will wait for the outputs of each job before publishing the results. I'll go into sequential or serial execution soon. But this is a really cool tool. I wanted to add it here. It doesn't really, it's not really reserved for DQM, but the Solus event mesh tool is actually really powerful and a really great way to visualize event meshes like this. So back to serial versus sequential orchestration. The point of breaking up DQM and ETL jobs and events is so that you don't have to worry about your ETL jobs not allowing your DQM jobs to finish, or decoupling your DQM and your ETL jobs, but you can still execute them sequentially. Here, you can also execute them serially if you want, but it does create some headaches. And I'm not going to say that there's a right answer or a wrong answer here. I'm just going to say that this is possible, where after your extract job is run, feasibly you could run your audit job. And then you can have your audit job run in parallel to your transformation and your load, or your load and your transform, and then fire off balance and control after that. Or you can have your load and transform job finish and then fire off audit sequentially. This is up to you. There's no right or wrong answer, and it's very use case specific. But there is some credence to firing these events off serially. And this is something you can only really do with events. If you were to merge these jobs together, then it's one big extract, audit, transform, load, balance, control, load, transform job. And then we're back to where we started before, where we have one massive job that doesn't really take advantage of events and does two separate tasks. So there's some things you have to worry about when you do introduce events, and this is true for events, period. You have to worry about your message bus being up. This introduces a separate level of operational complexity and operational overhead. If you don't have somebody working on your message bus at all times, use a managed service. And if you can't afford a managed service, probably use the free tier of a managed service or host it yourself in a very small reserved capacity. But if you're not prepared to take on the operational overhead of a message bus, probably not a good idea to do this. In addition, if you do decide to use a message bus that supports an event schema, you do have to be conscientious of event schema changes. If your event schemas change and you haven't updated your publishers and consumers to use the newest version of the schemas, then you could have some downstream repercussions. This is typically only a problem with message buses that are pretty large and have anonymous consumers. Anonymous consumers, and by what I mean by that is consumers that run without necessarily having to report to an upstream publisher. This is common in capital markets, where you kind of just connect to a feed and then you disconnect when you're done using it. If you've never connected to the feed in a long time, your event schema may be out of date, and then you won't be able to receive updates at all. Subscriber uptime. This is something you need to worry about in terms of like queuing or keeping track of your messages as they come across the event bus, keeping track of the order of the messages and how they should be consumed. If your consumer times out, for example, in the case of a Lambda function, if it times out while processing that message, then that's not really helpful at all. Step functions really good for this in the AWS space because step functions can handle retries, but it's not. That's something you do need to keep in mind if your DQM job is running for a long period of time. And then ETL outputs are your DQM inputs. This is important because if your ETL jobs don't output information the way your DQM jobs expect that information to be, then what's the point in using events at all? Or what's the point in decoupling these jobs at all? If you don't keep this in mind, then your DQM jobs might as well read from your source system of record directly instead of relying on events. So where can you go from here? You've implemented events on your DQM jobs. Now what? So the next thing you could do is to potentially run some quality management on your quality management jobs by having some custom CloudWatch alerts. The CloudWatch SDK is pretty great, pretty easy to use. And you can even, if you run these things on servers, you can set up the CloudWatch logging agent to pump logs out to CloudWatch for analytics and for monitoring. You can create, from there, you can create custom dashboards that will aggregate the performance of all these jobs and potentially allow you to come up with like a scoring mechanism to show overall data quality, like a score of 1 to 1,000 is your data of a high quality or not, using these aggregated metrics on CloudWatch. Then you could potentially run, put an API on top of this if you wanted to, allowing you to have some human intervention in your DQM jobs, allowing you to pull data quality reports automatically or on a schedule if you're interested. And depending on the volume of your DQM jobs or how many, or maybe not necessarily volume, but the rate that your DQM jobs run at, you could feasibly run KSQL over the top or some other streaming analytics if you were interested to help you aggregate the output of your DQM jobs into a nice small packet or into a nice small table that gets updated regularly, or what they call them K tables or K streams. You can potentially use that information using Kinesis Analytics or KSQL to further get a nice concise measurement of the data quality in your event, going over your event bus. I would not recommend KSQL though, or any really streaming analytics unless you have exceptionally high volumes or exceptionally high rate of DQM jobs that are running. The amount of overhead you have to put in to get that to work and the amount of insight you get back from it simply probably isn't worth it. It would have to be a very special use case. So I mentioned before at the very beginning, there's a bunch of different ways you can approach this, approach implementing a message bus and implementing a message bus for DQM specifically. Here I'm mentioning three alternatives to SNS, which is your simplest pub sub topic subscription model. You can use Kinesis. Kinesis is great for streaming jobs. If you have like a Lambda architecture for streaming data, Kinesis would be a great way to pump out events from those streaming ETL jobs to Kinesis, and then you can have Kinesis streams pipe that information to a Lambda, or you could even wrap this all up inside Kinesis Analytics, excuse me, which is built off Apache Flink. It depends on how much analytics you want to actually perform on your DQM job. It might be better to just use that for routing your streams to a downstream process like Lambda. Solus is great because it's a hybrid cloud solution. So you can connect using Solus Cloud. You can connect a Solus router in AWS to a Solus router in GCP or Azure. This is great if you host your data warehouse in GCP or your data analytics in GCP, and you have upstream services in AWS for like an OLTP database in AWS. That's a great way to, it's a great message bus for shipping off your data insights to another cloud provider without having to go through all the hassle of configuring like hybrid cloud solutions. And then there's always managed Kafka. I recommend the managed Kafka because managing Kafka yourself usually requires a full-time staff or a full-time operations team for messaging. So if you use the managed Kafka service, now you have an historical log of DQM events that you can query whenever you like. This is really nice if your ETL jobs write messages over Kafka in a way that does not require a lot of post-processing. So if your ETL jobs are writing intelligent messages, it really cuts down on the analytics work that your DQM job has to do. Right, so this is the demo. The demo uses AWS CDK. If you guys are not familiar with the CDK, it's a way of generating applications, kind of like CloudFormation, but using code. I'm deploying it right now. And basically what it looks like is you have your stack, which is a CloudFormation stack represented in code, and all the services that belong to that stack. So as you can see, I just deployed this stack and it's creating a CloudFormation change set using CloudFormation SDK. And if we go into the CloudFormation service in AWS, we could see this template or this change set being created. And it's running up the service, it's creating an API, which the demo doesn't really cover, but it is creating an API gateway endpoint. The thing that is most important about this service is that there's a DynamoDB table. There is a couple of Lambda functions that emulate producer and consumers. The definition for these Lambda functions are source resources EDQM zip. That's where the Lambda functions are, and they come from a producer and a consumer. The producer just takes the input and writes out an event. The consumer writes that event to DynamoDB. And then the other service that's pretty interesting is Event Bus, or the Event Bus. The Event Bus is Event Bridge, AWS Event Bridge. An Event Bridge is a really cool service. It's just another messaging service that, just like that diagram or that graphic I showed of all the different pictures of event buses, Event Bridge is the same thing. It's just another one of them. And what makes Event Bridge so cool is that it uses rule-based routing to route upstream events to downstream consumers. So in this case, I've defined some rules that we're going to create patterns for. And those patterns are going to route to targets. So if this pattern rings true for the event that's sent over, it's going to route the event to this target. And the target in this case happens to be the function that I pass in, which is the consumer function. So we're just going to wait for this thing to deploy. Any questions while we're waiting for this thing to come up? Cool. So our event bus is up, and we can see it exists here. I'm going to open it up really quickly. How are we doing that time? Okay, cool. Opening it up really quickly, we can see that this is the bus, and there are rules on this bus. These two rules route based on the source of the rule and the type. These rules, I was admittedly lazy when writing this demo, so that we're going to see that there are two events that get written to DynamoDB because the detail type and the source type are the same. And these are sample, these are fake class names that I've created. Your EDQM systems Airflow hook operation could write or could publish this event out, right? And this is the DynamoDB table. Come on. There we go. So this is the DynamoDB table. There shouldn't be anything in it. Yeah. Oh, that was the end of the demo. You guys got a sneak peek. So opening up Lambda, you can see that this table is empty. Opening up Lambda, we're going to go to our EDQM event publisher. And I mentioned before that it does technically hook up to API Gateway, but I don't have that part configured, or I haven't tested that part in a while, so I'm not going to do it here. But this is the code. It's written in Python. What we're going to do is configure a test event called audit.test. And we're going to pass this audit event. So what does this audit event really contain? It contains a JSON body where the source is this EDQM Airflow hook. And this packet shows the number of records read versus the number of records written. We can see that they're equal. You could go on and on with this. You could put as much information as you want. For the sake of the demo, I've just put just a couple of things in. The rest of this is specific to EventBridge, like resources and detail type. Those are monikers that EventBridge requires in messages that are sent across it. You could get pretty detailed with this if you wanted to, but for the sake of the demo, I kind of just kept it simple. So we have our audit test. Audit test. And now we're going to send it. So we can see the Lambda executed well. We have an event ID, and this event was sent over EventBridge because the source matched this event, and it hit the EDQM event consumer. So if we go back into Lambda and open up our event consumer, we go to the monitoring tab, we can see that the event fired, or that the Lambda fired. Uh-oh, did it not fire? Well, it must have fired. Oh, you know what? CloudWatch is behind. So we know the Lambda fired because the record is in DynamoDB. Remember, it's here twice because the EventBridge, there are two EventBridge rules that map to the same target, so it's here twice. But CloudWatch is behind. So this will come up, this will pop up saying that it's working in about 5 minutes because I don't have low granularity metrics on my account. because I only do this demo about once a month. So we will go to configuring another test, and we'll configure the balance event. Now, something to mention here is that I'm writing 3 separate events. In this case, the balance query here is an actual SQL query where I'm checking to see if a balance condition is true. And I'm expecting this response. So you can do some like string comparison there to make sure that the response is correct. But back to what I was saying, the thing that I'm doing here that's a little unique is that I'm sending 3 separate events to show the different processes and to show that balance and audit are 3 individual processes. You may not always want to send 3 events to trigger these processes because they are technically sequential processes. If you were to do them out of order, it may create some unexpected behavior that I'm not fully familiar with what that would look like. It may be advantageous to you to do that, but in this, I'm sending 3 separate events to show that they're 3 atomic processes that you would want to record in your data quality management process to ensure data quality without necessarily having 3 separate events do that. Typically, you would want just 1 event, and that would go to your orchestrator, like a step function or something. So we're going to create a control test now. This is our last event. And the control test is really just showing, hey, we're missing some records with these IDs. Can you start a new, and the downstream control job should read this and say, hey, I don't have, my downstream process is missing these IDs. Oh, I'm missing these IDs. Can we go rerun an ETL job with these IDs specifically? And then I'll be able to reintegrate them back into my downstream system. And that is that. So does anyone have any questions on that? One thing I would like to point out is that you can very easily tear down stacks in the CDK by running CDK destroy your stack name and then the profile name. In my case, this is the name of the profile that I assume, and it tears down everything that it just built up using CloudFormation, where it just tears the stack down.
Hey, Dan, I have a good question.
Yeah, sure.
This is David. I'm actually more familiar with Azure than AWS. I haven't done much with AWS. So I'm trying to struggle to fit this into the Azure cloud stack. Do you have any tips around that, or any references that you could kind of point to in terms of like bringing this into that world? Or and the other question I have is, are there any other like kind of generic design things out there that talk about these patterns, or talk about some of the things that you're doing there? Because some of this is pretty, I mean, I've been doing this for a long time, and I feel like you were speaking another language to a certain extent. So this is new for me, some of it.
Yeah, no. From the Azure world, in my experience, a great. I'm going to let you chime in on this too, Sam, if you have some insight, because I know you're an Azure guy. But in my experience, Azure Functions is the one-to-one replacement for Lambda. I like the Azure Functions UI because it's pretty cool. It's pretty easy to lay out exactly what needs to happen, but sometimes I feel like it's almost so easy to use that it's more difficult to build something that works well every time. Because of the drag and drop interface, we have to select everything that comes, all the different options. You have to know exactly what options you use.
Are you talking about Azure Logic Apps? Because Azure Functions is basically Lambda.
Oh, is that what? Okay, so okay, I'm thinking of Azure Logic Apps. I Azure Functions is a separate one then?
Azure Functions is Lambda, but for Azure.
Okay. So yeah, in that case, I would recommend everywhere I said Lambda, Azure Functions. And everywhere that I said something like, I know there's a drop-in replacement for SNS. I don't remember what it is off the top of my head. But if you're looking for something a little more complicated, like a comparison to Event Bridge, I believe Event Grid is the best service for that. I would shy away from Kafka and other services like that, just because there's so much that those services bring that you really don't need. You just need something to decouple upstream from downstream. And unless you're planning to utilize the event log to make your data quality management processes easier, I wouldn't use something like Kafka. In terms of other design patterns, it's kind of hard to know specifically without knowing your data quality management needs. What I've found is that people like to have they like to have a dashboard with a number that represents their data quality. And if you can break that number up into components where data quality for this type of application is represented by this value or this metric, data quality for this application is represented by this metric, then you can start to work backwards and build your data quality pipelines from there.
Okay, thanks. I guess it's part two of the question was, is there any like further reading or materials that you would recommend in terms of this topic?
Yeah, so I think there are links on this slide. Oh, maybe the links are broken. So a lot of the research that I did to support this came from a client engagement that we had where we implemented something similar. Additionally, it was more about combining the idea of fan-out events from event buses to, let me see if I can send you the slides because oh, here's the demos, there it is. Okay, here's the references. I'll paste them here.
Yeah, anything you want to paste here, we can go ahead and paste to the Meetup event itself, so people can kind of like, just reference it afterwards.
Yeah, the links didn't go through, but I'll paste it to the Meetup because I have the hyperlinks at the end of my slide deck.
Cool.
I'll even send the slide deck as well. But most of it comes from white papers and blog posts from AWS engineers about fan-out event architectures.
Okay.
Just applied to data quality.
Yeah, thanks. I think that's what I'm looking for.
Cool. So if anyone else has questions, if you could say your name first, that would be great, so we can know who's talking and keep track.
Oh, sorry.
No, you said David, which was nice.
I forgot to mention. I failed. Like I recorded it like right at the beginning, and I was supposed to ask everybody's permission for that. So this is our retroactive permission to record. So. So we'll post the recording after. I'll put it on YouTube and send the link out.
Cool. Any other questions, guys?
I have a question. I'm Eric Burnett. Hey, Dan. And so I wanted to know how much more should you expect to pay for adding DQM to your ETL jobs? Like how much more overhead would that be? And at what point do you consider even spending time on DQM, like as far as like workload of your ETL job?
Okay, so in terms of cost, I don't expect you to be spending too much more. DQM is not real, like the data you get from DQM is not really valuable long term. So if you use DynamoDB, you can probably just put a what do they call those? A timeout, a TTL on each record. So every week you can expect about the same size to your database because you really only care about week over week data quality. Lambdas are pennies. If you were to use Event Bridge is also pennies, so is SNS. It really depends on your volume, but you need to be on the order of 10,000 or more events or message or Lambda triggers per month in order to, or it's either per day or per month, in order to really seeing some dollars and cents costs. The big issue in terms of cost is operational costs and development costs. Everything I described here requires a kind of thorough understanding of AWS infrastructure or cloud infrastructure more generally, because it does apply to Azure World or GCP. So that does introduce some overhead. If your team's not ready for that, then you may find that you're creating more tech debt than you're willing to pay for. But once you get past the cloud adoption process, and once you're willing to accept that managing DQM, even in the short term, will help improve your ETL processes, then it's definitely worth it. The only thing that makes it not worth it is if you're not utilizing your data warehouse. If you're not utilizing your data warehouse for building models or for running large aggregate queries over months and months of data, then it's probably not worth it. You kind of run into this space where people are creating data warehouses because everyone has a data warehouse and they're not using it to improve their line of business. So if you're not using your data warehouse or your data lake to improve your work, then don't worry about data quality, because it doesn't really matter what's in there.
Thanks.
Thank you.
Hey Dan, my name is PG. If you're using Airflow already, what are your thoughts about embedding the audits messaging, or or recording of the audits basically on the operator, on custom operators?
Yeah, so it's funny you mentioned that. This is exactly what we did at the client site. We would publish a message in the operator itself, or individual tasks. Like I touched on it before, the project never matured to a point where we were able to really externalize and decouple those two processes, but the intent was always to have a separate operator publishing these events after individual tasks. So using Airflow specifically, we would start the job and publish a message that said the job started. We would start a task and publish a message that said the task started. And that's what, and our back-end audit job would receive all of these messages and aggregate them all together into a temporary store. And that store would show the audit trail of what happened in that Airflow job across runs. Looking back, it may have been more, considering the Airflow example specifically, it may have been more, what's the word? It may have been more advantageous to utilize the backend database, the Postgres instance that Airflow relies on, to get that information, because it is redundant information that you're storing. But then if your Airflow, or I'm sorry, if your orchestrator changes, now you're locked in. You have that Airflow backend, and you're pulling data quality information from Airflow's Postgres database. So you're locked into Airflow now forever. And if you're not willing, if you're willing to accept that, okay, that's fine. You're probably safe querying directly from Postgres. If you're not willing to accept that you'll be on Airflow forever, it may be a good idea to just have a custom operator where you just fire off an event and let your message bus handle the rest. Especially with Airflow too, because it's so extensible, it's so easily configurable. You can really get a lot out of it.
Thank you.
Thank you.
Any other questions, guys? Okay, cool. Well, thank you so much, Dan, for giving our talk tonight. This is, I think, was a great topic. Despite David heckling over Azure, as usual. No offense, David. I'm kidding. But yeah, I think it was a good logical progression from ETL, because I think a lot of us are familiar with that. This is my first time hearing about DQM, so it was nice to get a little overview and then just kind of see it in action in AWS. So that was nice to see. Thank you very much. I will make a few announcements real quick. So first off, you know, again, I work for Ippon now, which is great. If you guys want to know more about like the ABCs of DQM, Dan has a few blogs, and in general, we have other blogs out there. I'm publishing one soon, so be on the lookout for that. Be sure to like, subscribe, and comment on the LinkedIn when it drops. So if anyone's hiring, feel free to go ahead and, you know, pretty much do a little plug for that. Or if anyone's looking for jobs, you know, we I don't think we did it for the last couple meetings, but you know, it's something we do in our in-person meetup, and so I'm more than happy to continue facilitating it, even if it's virtually. I'll kind of stop talking for a second, so in case anyone wants to speak up.
Hey guys, this is Peter from Ippon. You know, we're hiring data engineers across all our offices in Richmond, DC, and in New York. So if you guys are interested, feel free to reach out. Either I'm on the RVA data engineering meetup Slack as well, so you feel free to reach out there. Or I could also provide some details within that Slack as well.
Cool. Thank you very much, Peter. So our next meetup, I haven't posted it yet. Unfortunately, I've been slacking a little bit, but we already have it. I don't think we have a date just yet. We might have a date. I'm not sure. I'd have to. Oh, looks like we have July 22nd for the date. So it's basically going to be Chase Greco from CoStar. He's an ML engineer there. He's given a few talks around the VCU area. I know Chase is in the call right now, so if you want to correct anything I'm saying right now, feel free to go ahead. He's got his master's from VCU in computer science. The talk will be on near real-time APIs for model pipelines in Amazon Web Services with SageMaker and Lambda. So sounds like a cool talk for AWS folks out there who are interested with machine learning. It's a hot topic right now. I'm interested in it myself, so that'll be cool to hear about. But yeah, I mean, that's pretty much it. Thank you guys so much for showing up. For our new people out there, thank you so much for joining us virtually. I'm seeing a handful of names I haven't seen for the first time. David told me that some of our folks that came here today or RSVP'd for the event are in other countries like France, Laos. So that is very cool to see that we're, you know, becoming worldwide. You know, it's a little Richmond meetup group. But yeah, that's pretty much it. You know, I guess we're gonna close down the call soon, but thank you guys for coming so much. Yeah, I hope you enjoyed Dan's talk. And Dan, thank you again for presenting.